welcome to Media Technology Center, OPG University, Raigad. I am Prashant Kumar Jaina, working as the Assistant Professor in Department of Electrical Engineering. Today, in this lecture, we are going to find what are the different operating power factor of electrical machines. So, basically, in the interviews or any kind of Viva questions, you can always find the question why induction motor operates at low power factor. So, that things we will discuss in this lecture. So, what is the power factor? The formula for power factor is that is equal to P by S. P is known as active power and S is known as apparent power, or some call it complex power, and it can be written as P by root over of P square plus Q square. And what is Q? Q is known as reactive power. So, and power factor, the formula for power factor we can write it cos pi. So, what is the operating power factor in case of an induction machine and synchronous machine? So, first we will initially know what is actually active power, what is reactive power, what is apparent power. So, active power is the actual amount of power being utilized to give the output. Suppose the fan is rotating. So, the amount of electrical energy it is consuming to rotate the fan is known as active power, and apparent power, it is the total power, and between that we have another component that is called reactive power. Reactive power, what is the definition of reactive power? It is the power that is neither being consumed nor being absorbed. It travels from source to load and load to source. So, the nature of reactive power is magnetizing nature. It is used to magnetize the core or the air gap in an electrical machine. So, in synchronous machine or induction machine, we will find two different things. What is that one? A synchronous machine, whether it may be a generator or it may be a motor. In synchronous machine, we will find one rotor and another one is stator. This part is called stator and this part is called rotor and this part is called air gap. So, in synchronous motor, if specially we will go for the power factor, when we are going for power factor, let us see for motor, it will be very easy. So, in synchronous motor, I am saying that we are connecting a three-phase balanced three-phase supply to the starter and we are connecting a DC supply to the rotor. So, that means synchronous machine is otherwise known as double excited machine. That means starter is connected to one kind of supply and rotor is also connected to a supply. Both the starter and rotor are doubly connected, that is why it is known as doubly excited machine. So, so you can say that 4.44 is constant, n is the number of turns that is constant. If E by F is constant, that means phi is constant. So, we can say that in our supply system, your balanced supply, the voltage magnitude is constant and the frequency is also constant. So, if V by F is constant, so the flux that is in the air gap, the flux in the air gap will also be constant. That means, so for a constant amount of voltage magnitude and frequency, the amount of flux in the air gap will be constant. So, let us take the example. Suppose we are having we require the air gap flux is required a 5 Weber of flux, and to generate that 5 Weber flux, we need a 5 ampere currents to be flowing. Let us assume that one. So, if my air gap is requiring a 5 Weber amount of flux to be generated under that condition, and for that the 5 ampere current is flowing. So, if my DC supply given to the field excitation, that is excitation voltage, is enough to give 5 ampere current, that means it will generate a 5 Weber of flux in the air gap. Under that condition, the amount of flux required by the air gap in the air gap is constant. So, we can say that it is otherwise known as normal excitation. So, in normal excitation, what happens? The machine neither absorbs the reactive power nor delivers the reactive power, because the machine by itself is self capable of generating the required amount of flux. The self capability is being provided by the external DC supply given to the rotor. Whereas, if my DC supply given to it is able to produce a current of 3 ampere. If my excitation is giving a current of 3 ampere, it will generate a flux of 3 Weber. But the air gap flux is required is 5 Weber. That means you are having a shortage of 2 Weber flux. So, how to get the 2 Weber flux? Under that condition, the motor will draw a reactive power from the supply to compensate that 2 Weber flux. So, what will happen, and this is known as the system is under excited. This is known as under excitation, or we can say that in this situation the system is under excited. Under excited condition, the system absorbs the reactive power Q. So, it operates in a power factor of, we can say the lagging power factor. Similarly, if I have a supply of 10 volt supply and let it be producing a 10 ampere current and it is producing a 10 Weber flux, but since the V by F ratio has been maintained constant, the amount of flux required 5 Weber is required, but we have producing 10 Weber flux. So, what will happen? The system machine will deliver the extra amount of reactive power to the source. So, it is known as over excitation, because we are exciting the system that is more than the required amount of the flux. This is called over excitation. Under this condition, it delivers the reactive power, that is why it is operating under leading power factor. That means I can say that by changing the flux, if the flux is self capable of generating the required amount of flux, it is normal excitation. Here the system operates under unity power factor. It behaves like a resistive load. If it is under excited, it is absorbing the reactive power. It is behaving like a inductive load. If it is over excited, it is delivering the reactive power. It is known as capacitive load. That means a synchronous motor can either operate in normal unity power factor, lagging power factor and leading power factor. Whereas, in case of an induction machine, that case is not possible, because the induction machine thus is a single excited machine. This external supply is absent. That means the system is always under excited. There is no external source provided to produce the air gap flux. When there is no external supply is produced to produce the air gap flux, thus at the initially when you start the induction machine, it will draw heavy amount of reactive power from the source. So, when it will draw a heavy amount of reactive power from the source, the Q denominator increases. So, the power factor will decrease drastically. So, that is why you can say that induction machine operates under lower factor poor power factor, whereas synchronous machine can operate under unity power factor, lagging power factor and leading power factor. Thank you. हो गया.